Good morning, everybody, and welcome to lesson 9.3 on properties of other quadrilaterals. Today we're going to look at polygons that do not have quadrilaterals that do not have two pairs of parallel sides, so quadrilaterals that are not parallelograms. Our first one is a trapezoid, and the definition of a trapezoid is that it is a quadrilateral with exactly one pair of parallel sides. That's our key idea. A trapezoid has two base angles, or two pairs of base angles. So this is a pair of base angles, this is a pair of base angles. Two legs, leg, leg, and two bases, base and base. There are also two pairs of supplementary angles. Supplementary angles in any trapezoid. Below, those pairs are P and Q and R and S. Notice the pairs are on different legs and, they're on the same leg but touch different bases. So each angle that touches the leg will be supplementary to each other. All right, let's keep going. The mid-segment of a trapezoid is drawn between the two midpoints of the legs. Remember, we did mid-segments when we were talking about triangles and different points of concurrencies. Mid-segments there were also drawn between the midpoints of the sides. The midpoint is parallel to both of the bases, and its length is half the sum of the bases. The midpoint is therefore mid-segment is actually the average of the bases. It's really quite easy. So here, if we make QR 6 and PS 20, TU has to equal the average, 6 plus 20 divided by 2. It's 26 over 2, which is just 13. We can, of course, make this math slightly more complicated and have to find other things. If I want to find PS as opposed to RU, so wanting to find one of the bases, I set up my equation just the way I did. So the mid-segment, that's 19 TU, equals the average of the bases. Well, one base is 9, and the other base is PS. I don't know what PS is. Divided by 2. And I simply solve the equation. Multiply by 2 both sides. Here I get 38 equals 9 plus PS. Subtract 9, and I get 29 is equal to PS. We can also do this algebraically. So, for example, remember TU is my mid-segment, right there. I can say that TU, 3x minus 6, is equal to the average of those bases. 2x minus 1 plus 25 divided by 2. Just like I did before, I'm going to multiply by 2 on both sides to get rid of the denominator. So I get 6x minus 12 equals 2x, I'm going to go ahead and combine those, plus 24. Get all your x's on one side, all your numbers on the other. I get 4x equals 36, so x is 9. We have a subcategory of trapezoids called isosceles trapezoids. And an isosceles trapezoid is a trapezoid with congruent legs. Okay? If a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. And if it's an isosceles trapezoid, then its legs are congruent. Okay? So, taking a look at these examples, in this example, I see that I have two angles, but the angles aren't the base angles. Or they're not a pair of base angles. They're two angles lying along the same leg. So when that happens, they must be supplementary. Plus 60 plus 8x minus 40 must equal 180. I want you guys to finish the problem. Oh, wait, it's not its legs that are congruent. Its diagonals are congruent, Doy. Sorry, guys. The diagonals are congruent. I know that made no sense. Well, the legs are congruent, but the property is that the diagonals are congruent. So let's look down here. If BD equals 9x minus 37 and CA equals 3x plus 5, find the length of each diagonal. Well, again, in an isosceles trapezoid, the diagonals are congruent. Therefore, I can set those two values equal to each other. And I'm going to solve. I'm going to subtract 3 over here to get 6x. I'm going to add 37 over to the other side to get 42. So I get that x is 7. If I want the length of each diagonal, then I simply plug 7 in. Doesn't matter which one because they're the same. I do 3 times 7 plus 5, which gets me 21 plus 5, or 26. Or, woo, yeah, 26 is my answer. Good. All right, then we have a third category of parallelograms, and those are trapeziums. And trapeziums are quadrilaterals with no pairs of parallel sides. Now, I'm going to just go out there and say this, guys. This is a definition that is only recognized by the U.S. If you go to the UK or Canada, trapezium and trapezoid end up being the same thing. So just note that this is a U.S.-only definition, but it is used in the U.S. So trapezium is a quadrilateral with no pairs of parallel sides. All right, so a kite is a special kind of trapezium, and it is a quadrilateral where exactly 2 pairs of consecutive congruent sides. Now, consecutive in a quadrilateral, they're going to be 2 pairs of sides that touch that are congruent. So, looking down at my picture here, WX would be congruent to WZ. They touch, and XY is congruent to ZY. 2 pairs of consecutive congruent sides. The opposite sides cannot be congruent because then we'd end up with a parallelogram, and it would end up with 2 pairs of parallel sides. A kite is also a trapezium. Okay? If a quadrilateral is a kite, then its diagonals are perpendicular. So looking at that, kites, when we've drawn the diagonals, are actually split into 4 right triangles. It's going to be very useful for us. One and only one diagonal will be bisected by the other diagonal. So looking at this, XZ is bisected, I guess I have to do 3 ticks here, by WY. But WY is not bisected by XZ. So this would make WY the perpendicular bisector of XZ. One and only one pairs of angles will be congruent. So in the diagram below, angle X will be congruent to angle Z, but nothing else will hold. So now if we look at some examples, all right, I've got some fun things going on here. There are actually really 2 problems in this. The first is this right here. I know that one diagonal bisects the other diagonal. So I can safely assume that those 2 values will have to be equal because they each are 1/2 of the bisected diagonal. So I want you guys to finish this problem. Now, the other one has to do with the perimeter. Well, before I can look at perimeter, I have to label the remaining sides. If this side is 3y, this side must also be 3y. And if this side is 6y minus 2, then this guy must also be 6y minus 2. Perimeter simply means the sum of all sides. So when I add 3y plus 3y plus 6y minus 2 plus 6y minus 2, I have to get to the perimeter of 86. Now, let's combine like terms. 3 plus 3 plus 6 plus 6 is going to get me 18y minus 4 equals 86. Add 4 over, 18y equals 90. Therefore, y equals 5. All right, now I thought it would be useful to do a summary of all of the different kinds of quadrilaterals we've learned and their properties. So, first is the parallelogram. Things we know about the sides. In a parallelogram, I know that opposite sides are congruent, and I know that there are two pairs of parallel sides. When it comes to their angles, I know that the opposite angles are congruent, and that consecutive angles are supplementary. And I know that the diagonals bisect each other. That's all I got for parallelograms. Now, a rhombus has everything a parallelogram has, so all parallelogram plus more. In a rhombus, the definition of a rhombus is that all sides are congruent. Okay? And there's really nothing special about the angles in a rhombus other than what's already true for parallelograms. The diagonals, on the other hand, not only are bisected like they were before, they are also perpendicular to each other. So, let's look at a rectangle now. In a rectangle, it has everything a parallelogram has, because it is a type of parallelogram, plus sides, nothing particularly special. It's the same thing as here. The angles, it's equiangular, which basically means they're all 90 degrees. Oh, and here, this would be their equilateral. Right? And the diagonals happen to be, so we're still bisected. The diagonals are still bisected, and they are congruent. All right. Let's look at squares now. Squares have everything listed above. So they are equilateral. Okay. They are equiangular. And the diagonals bisect each other, are congruent, and perpendicular to each other. Now let's move out of the realm of parallelograms and into slightly more interesting things. Trapezoids. Trapezoids are defined as having one pair of parallel sides. Other than that, there's really nothing else I can say about trapezoids that help us. The angles in a trapezoid, and I'm going to draw this, right? These guys here are supplementary. And in a regular trapezoid, not a whole lot else I can write. Now, there's really nothing in a regular trapezoid that helps me about the diagonals, but I do want to remember, so I'm going to write this in a different color, about the mid-segments. Mid-segments, mid-segment, singular, is the average of the bases. So that's an important thing to remember. Okay, guys, the video, I'm about to run out of time. I want you all to try to fill out the last three. I'm going to check them in class, and we're going to go through them together. So have a lovely evening, and I'll see you all later.